right away. The base idle ignition table. This table is what we need to focus on for right now. This is taking a look at the idle target error as I was just talking about previously. This is looking at 0 RPM, means that we're hitting and we're operating right at the target idle. So if I set it to 1400, that means we're right at dead on at 1400. Now, if I'm starting to go overshoot the idle speed, we're going to be finding negative calculated idle RPM error. So from 200 RPM over my target, let's say it's 1600, so my target's 14, I'm idling at 16, I'm 200 RPM over, it'll take a look at the spark timing here, I'm commanding at negative 200. Likewise, if I'm undershooting the target idle speed, so if I program target idle speed at 1400, I'm at 1200, it'll look at my value here at 200 under my target idle speed. We'll use spark timing to be able to manipulate the engine's torque output, to be able to get the idle torque back in line when we get the engine fired up and running in the next tutorial, to focus our idle torque so that we're hitting this target idle speed. So just to be clear here, I've opened up the throttle plate ahead of time. I've used a manual throttle stop screw. I've opened that up. I've opened up and gave myself a surplus of airflow coming into the engine from my throttle plate. We're going to be controlling the idle torque, which is when we're at idle, we have airflow and spark timing to influence the idle torque. Too much idle torque, we idle too high. Too little idle torque, we idle too low. When we're having our idle torque just right, we'll hit our target. So we're using, in this case, fixed airflow coming into the engine from the throttle plate being open, and then we're using our spark timing to guide the idle RPM to the target and essentially manipulating our idle torque. So all we're doing here is moving idle torque around with spark timing, but this table is going to be set up in a way that we can use this and control everything. What I'm going to do right now is set this entire table at something like 20 degrees. This will source the spark timing at idle for 20 degrees. We can adjust this as needed once the engine's fired up and running and kind of feel this out. I'll talk about that process when we get there, but this will be a good starting point for any engine. Now, one thing I do want to point out is it uses this idle spark ignition timing. We're commanding 20 degrees. This will override whatever is coming from my main spark timing table in the idle area here. So if I take a step backwards, jumping into ignition, jumping into my main ignition table here, we've commanded 20 degrees here. Just so happens that's going to coincidentally be what we've commanded in the table here. But if we command it 5 degrees here, let's say at idle conditions, this area right here, we hit 5 degrees. It will not use this 5 degrees in the table as the timing for idle. It'll use 20 degrees coming from our idle spark feedback. That's where the timing is going to come from. As soon as we exceed the conditions that we programmed, 2% throttle, 2 kilometers per hour or higher, or 1200 RPMs of actual RPM offset from the target, it'll kick itself into our main spark timing table here. So it'll actually source the values from here rather than the idle spark. So it flip-flops between the tables, and we need to make sure that transition's smooth. We'll talk about that the next tutorial. It's getting ahead of ourselves, but that is going to be the purpose of the idle ignition control. Now the Lambda Control wideband, we want to set this up. We are going to be using this to guide us in making our changes and dialing in our fuel and airflow. Go into our Lambda Control. We're going to see our engine temperature lockout here is 20 Celsius. I'm going to go and lower this down to something like 0 Celsius. So it can assist in the cold starting and the warm-up enrichment and trimming out any kind of offsets that we need to get our fuel mixture right. We'll talk about that when we do cold start video. Make a little bit more sense. We want to lower that down. RPM low lockout at 500, so anything below that, it'll ignore the Lambda feedback. Let's go and set the high RPM lockout to 12,000. We want this to constantly run its Lambda correction, even at high RPM, full throttle, part throttle, whatever it's going to be. Recovery delay here. This is going to be how quickly, after we hit a limiter, that it comes back in and starts to trim. In this case, I'll do it for a half second. Post-start delay, it's going to be how quickly it waits till the Lambda control, the wideband feedback, starts to go in and make corrections and adjustments in the short-term and long-term corrections. Now what we need to note about this is this wideband takes 20 seconds to come online after it's been powered on, meaning it won't output a valid reading from this AEM inline X-Series wideband for 20-30 seconds. The heater circuit has to heat up, it has to go in and actually start to populate, and then once it heats the sensor up, it's valid and it sends a signal out and it'll actually give a valid Lambda sensor reading. Now in this case, we need to wait until that sensor is actually accurate in order to use it for Lambda control. So we're going to say here, post-start, we need to wait 30 seconds to be safe on this wideband. In this case, it's outside the range, so we'll say 20 is the highest. 20 seconds before it's going to use any readings from the Lambda sensor for any kind of correction. So We need to make sure we're accounting for that. Now, different widebands will have different warm-up periods, but the AM widebands are 20-30 seconds typically. Let's use our escape key. Long-term fuel trims.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.